Hello, 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 Cheers, Kevin here, and welcome back to another episode of Well True Learn. We are well and truly learning, so good for us. Today, we're starting with task number 30. Our startups are doing great. Our shares are worth some amount of money. Actually, let's jump into CBay and see what we might be able to buy to increase our awesomeness. Okay, perfect. Handmade tambourine. Data transfer speed. The data transfer speed does seem to be a thorn in my side at just about every turn, but at the same time, increasing the node work speed and the data transfer speed and decreasing the server. I don't care about the server cost. I mean, I do, but whatever. Yeah, I know I don't care about the server cost because usually we're ending up just a little bit too slow, not just a little bit too expensive. So I'm not constrained by server costs for the most part. Let's get this. How much money do we have? We still have 5,000. We're spending a lot of money, but that's fine. Let's do this. Handmade tambourine. All right. Time to look at fast data sorting. Good morning. We have a scientific satellite that aggregates data from our geomagnetic researches. But we need to liquidate our satellite to put the new one onto the orbit. You need to extract all the information about geomagnetic activity and sort it around. Okay, let's do that. Oh, we need to be 100% accurate. And we need to get it all done in 45 seconds. I feel like we've already done this, haven't we? Oh, no, we're filtering on shapes and color. Ugh, okay. Okay. So we're filtering, so we're doing this is, yeah, not, I'm still confused about exactly how this is working. Okay. RGB sort, for whatever reason, despite the fact that it is slower, it seems to be faster to put this in front, and I don't, for the life of me, know why. So we're going to create 3 more of these. I guess we're spending a lot of money on this because I'm being lazy about it. We're going to sort by RGB first. So this is the red, and if it's a circle, great. If it's not, garbage. I'm just going to put 2 trash cans in here. Everything else is garbage. And yeah, we need to be 100% accurate with all of this. Okay, so this is green. If it's a square, great. Everything else is garbage. And then blue, if it's a triangle, great. Everything else is garbage. And call that good. We call that probably too slow, maybe? We're not getting data down here fast enough. Are we processing? We're not chewing through the data as quickly as I would like. But yeah, no. Okay. We weren't too far off, honestly. We were just 1 piece of data away. Ugh, that's frustratingly close. Is there a... Man? But there's not an easy way for me to fix that. All right, well, let's throw money at the problem. We can throw a quick sort in front of here, pay some additional server costs, and this thing will operate a lot faster. I mean, the whole thing. And since, yeah, that should mean that we're good. I mean, although if it's the shapes that are blocking us up, then that's not necessarily going to help, is it? I'm very confused about these numbers here because I think they're perhaps misrepresenting the real situation. I don't know. Okay, but that succeeded. Fine. That is expensive. We're spending lots of money. And for a decent number of seconds, man, I hope we don't go broke off of this. I should have double checked to make sure that the cost was less than the amount of money that we actually have. I think we're going to be okay. But that was close there. Okay. So we have succeeded. We have made $8,000. That means we can jump into the bank and see. Ooh, private mail. Mail from Lottery. Hello, you've registered in the prize-winning lottery prize pool. We are glad to inform you that your registration number 1 in our last drawing. Congratulations on winning. The money will be sent to the bank account stated during registration. Nice. Free money from Gold Lotto. Let's look on CBay and buy ourselves some more hardware. New hardware. Data transfer speed by 10%. Ooh, I like that. I really like that. The socket processing queue size, I mean, I suppose is helpful. Maybe that does... maybe that is worth throwing some money at. Maybe that's actually what's kind of secretly been causing some of my issues. We'll do that. And yeah, the companies are still profitable. I guess Evolver is starting to decrease a little bit, maybe. But let's take another job. Hello. The Smart System of Educating and Training by Sky Network. We are representing the Center of Combat Training. We train soldiers to react correctly in different battle situations. We are in need of an algorithm that can choose the situation where the soldier would learn and adapt to his reaction. This would help prepare soldiers for the difficulties of war and reduce casualties to a minimum. All right, let's accept this. 70% accuracy. And just doing... Ooh, perceptrons. Let's look at perceptrons. What are perceptrons? In the test run, perceptron reduces the amount of errors while trying to predict the shape of elements. In deploy run, perceptrons only predict shapes. Oh, yeah, we already talked about this, didn't we? We've already looked at this. This is a trainable thing. And in fact, haven't we already done stuff with this? Custom nodes. Okay, no custom nodes. Fair enough. This thing, yeah, we get to train this. Right now, its error is 75%. Isn't it? Yeah, wasn't there a whole thing about Rosenblatt's perceptron? Oh, it's just a perceptron for shape. The perceptron wasn't... Yeah, unlike Rosenblatt's perceptron. Perceptrons can predict more complex nonlinear dependencies nowadays. Okay. They are the basic elements of each neural network. Okay, so neural networks are fun. CST machine sort, and this is 0.5 seconds. So this is faster, I guess, than other stuff we've been doing. We just need to train it to the point where it becomes a lot more accurate. And it's already down to 9% accuracy. That's great. It does get up to 10% accurate if we let it train too much, though. And this may be an overfitting case. Let's continue training and see if we can... It's not going to get better, is it? No. Okay, let's stop there then. And yeah, go ahead and release that. Let's rent the servers. Wait, what is... Oh, ACC timer. What is ACC timer? Ah, now I'm confused. What was that? ACC timer. That's different from what we were looking at before. I guess accuracy timer? How fast? Oh, how fast it takes to get to those individual things. Okay, so that was interesting. The accuracy timer was not a global one. It was one based on each of the outputs. All right, survivors, a cat meow. Cluster viruses into types. A strange virus. Alarm! A strange virus is killing people in the Procyon City. We can't understand what type of virus it is that. Please help. This message was sent to all programmers in the world. All right. We better buy the big guns for this one, I guess. Right? Node work speed, data transfer speed, like this. We should try and pick up some of the cheap ones too, so that we're not always crazy behind. Okay, I didn't spend too much. Good, nice. Good job, me. Let's accept. All right, what are we doing? Just sorting by color. Ooh, gradient descent. Increase error reducing speed. Each element has a small error fixed value. This block increases this value. This node isn't working in the release run. Okay, so this is not working right now. And stochastic gradient descent. Oh, this... Okay, this also isn't working. That's kind of a bummer. We'll just have to use a regular perceptron, I guess, then. Perceptron for color. Huh. Okay, so there are these additional nodes that are better, that I guess can help us, but... Oh, now our error got worse. Why did our error get worse? We are training. Okay. Our error has gotten worse. In the deploy run, it only predicts colors. Okay. This error is not getting any better. This is a big bummer. Have we run into like the end of what we're able to do in this alpha release? Maybe. I hope not. Yeah, no, the error just gets worse as we throw data into it. Let's try these broken things. Gradient descent, input and output. Let's try that. Does that do anything? It does. Okay, so this does work. Okay, gradient descent. So this is kind of... Gradient descent and stochastic gradient descent are interesting. So gradient descent, the whole idea of gradient descent is that if you have a solution to a problem... if you have a solution to a problem and it gets a certain error score, you try and see if tiny tweaks to the problem will give you a better error score or a lower error score. Stochastic gradient descent is one where if a tweak in a particular direction gives you a much better error score, then you move very far in that direction. So this is faster. The way of representing this is kind of a bummer. Okay, so this does get the perceptron down to very, very low. Which is great. Of course, we've got to get this to stop on something reasonable. This is not... Okay, can I get it to stop? No. Training. It's overfitting, so it's good. Okay. Can I get this to stop at that 9%, please? Thank you. All right, let's call it that. We don't need to train it anymore, I guess. We'll just take the training off, and we'll release that. Because then it'll be faster anyway. And... Okay, so now these individual timers are going down. There we go. And servers used 1. Cool. Next project. Good day. We are engaged in repair and maintenance of aircrafts. Now we need to predict all possible problems which can happen in the air. Can you make such a system for us? All possible problems? All right, sure. Ooh, deep neural nets. There are neural networks that solve the so-called XOR problem, an unsolvable problem for Rosenblatt's perceptron. They have one hidden layer between the input and output layers. Such networks are called non-deep. If the network has more than one hidden layer, it is called deep. The deeper the network, the more complex dependencies it is able to recognize. For example, the current image recognition networks include several thousand hidden layers. Amazing, isn't it? It is indeed very amazing. Okay, perceptron color again, stochastic gradient descent again. Do we have this? We do have our RGB machine sort already, which is, we've already kind of done. And we already trained it. We trained it to be 9%. Pretty darn accurate. So I think we're pretty much good here, because this is just this was the prior solution, right? Okay, it saved how to save this? Yeah, RGB machine sort, and we got our perceptron down to 10%. This needs to be 90% accurate. Okay, let's not train. Let's just do a test run, I guess. Nope. Why are we not getting... Oh, I see. So this is actually, it's going to do a countdown. We need to be accurate. We need to stay above the accuracy threshold for this amount of time. It's no longer a matter of getting enough data into that bucket. Interesting. Can we throw stochastic gradient descent in front of this for a while? I'm just curious. Oh, no. Okay, so as long as we're up... I'm confused. Well, okay, let's build this up again, because why not? Lose stochastic... Blah, blah. Stoich's asterisk, blah. I don't know. Oh, no, we need to train this. Thank you very much. And the air's getting low, but then it kind of stays... It kind of flickers back and forth between stuff. It's not getting better over time at this point. We may have reached kind of a peak of what we're able to do. Can we throw 2 stoichs in front of here? The thing is, this doesn't really represent... And now... It's kind of a bummer because this doesn't really represent what we're doing anymore. Which is kind of frustrating. Do we get... Yeah, we don't get other stuff, so... Can we use... Are these... If we've trained that one and we use this one that's trained, I guess, on a different data set, does that mean we're going to get different... The errors can reduce because they've both been trained on different data? Maybe? Oh, no, I don't want to be training. Test run. Just stay above that accuracy. Yeah, okay. I guess that seems to be working. I mean, it's slower, but since these 2 perceptrons were trained on different data sets, we're getting decent error handling, because one of them gets 90% of them right, the other one gets about 90% of them right, but they're getting different 90% right, and so since we're checking with both of them, we're okay. I don't know if that's entirely how this is supposed to work. But I guess maybe. Maybe operating on both data sets is a useful thing. Yeah, although that's... I guess, wait, accumulated R machine. I guess that's what that means? All right, well, fair enough. Let's take another look at more stuff. Let's buy some equipment. It is equipment time. Hardware. Oh, man, we're actually finally starting to put a dent in the hardware we're able to get. Yeah, we should be able to get everything now. Increase node work speed and decrease the server cost. Let's hide we hide locked elements, or unhide locked elements. Oh, we have bought all the hardware we can buy. Okay, cool. So that's all that we can get. Now we can start buying cat skins, I guess. Nodes we're not going to be able to get. Yeah, we could start buying fun things for our cat. That sounds like fun. For merits and testing, you can get the game developer one. We needed cyborg stuff, definitely. There we go. Oh, nice. We can toggle the outfit. All right. It's been a while. It's been too long. All right. How are our companies doing? Day 5 of 7. Recommendation system. We need to build a smart system that can help students learn English faster than usual. The system needs to choose courses and lessons for students the right way. Can you make it? You bet your bottom. Ooh. Neural networks architecture, ReLU. In neural nets, programmers use a vast range of different neurons. Inside each neuron, a math function is located. For example, Rosenblatt's neuron used a linear function. Simple neural net, which can solve the XOR problem, uses ReLU function. These functions are called activators. For different tasks, people use different activators, which will be more suitable in different cases. To solve more difficult issues, a combination of neurons with different activators is used. Okay, cool. Okay. So now we're doing sorting. God, this is going to be weird. All right. Okay. We get a lot of stuff. Accumulated red machine, RGB machine sort, CST machine sort. I guess we chain these, right? RGB machine sort and CST machine sort. So red can go up here and let's, yeah. Red, green, blue. Okay. So if you're red and you're a circle, clap your hands. And we'll probably need to do some parallelism, but we'll see. Green, and you're a square, clap your hands. Actually, let's put another trash here so that it looks pretty. Blue, go down there, clap your hands. And let's see if this is even a little bit close. Let's just do a test run. We're not going to train these. Although I don't know if training matters when you're using stuff that's already set up. Yeah, our accuracy threshold is fine. The accuracy thresholds are fine, so yeah, we're good. So filtering in color first, and then, yeah, so it's just that we have to stay accurate for this total amount of time. And then if we don't make a mistake for that amount of time, we're good. So it's interesting that the requirements changed underneath us a little bit. All right, next one. We've detected some possible dangerous asteroids in space. Now we need to predict the trajectories in order to avoid a possible catastrophe. Help us to learn which ones of them are hazardous. Some of them may destroy the moon. Oh no, I like the moon. I'm a big fan. This is just a color sort, and we already have that, don't we? RGB machine sort. Seems like it to me. G. Boop. Ba-doop. Nope, don't train. Just test. Is this going to be too slow? It doesn't seem like it's going to be too slow. Oh yeah, and so now we are looking to get X amount of data into here. And okay, this is slowing down, so maybe we do need some parallelism, but maybe not though. We may be okay. I'm not sure. Ugh, not quite enough. All right, 132 out of 150. Ugh. Oh well. RGB machine sort. Do we get any nice, happy? Nope. All right, fair enough. We'll just copy this. Come on. There we go. Come on, give me my. There we go. The copy paste mechanism is a little glitchy, which interesting. It reminds me of honestly the glitchiness of the copy paste in Kerbal Space Program, which makes me wonder if this is a Unity thing, maybe? I don't know. I mean, that should be more than enough. So we're using the exact same thing. We're just chewing through the data a little bit faster. So. And there we go. More expensive than probably we needed. Maybe if we went back and we were able to train things to be a little more accurate, but whatever, it's fine. All right. Okay, so one thing I will say about this game is that it doesn't always do the best job of letting you know kind of where one of your solutions is potentially slow and you should go back and revisit it, because it's very hard to distinguish when, like in this exact case, is this because I did something bad, or is this because, well, you know, it's just too demanding and I do need to parallelize stuff. So they're using money as kind of the thing that shunts you back into to go back and try and optimize. But right now we're not short on money, right? So there's not an incentive for us to go and look at stuff. So yeah, that's a little bit of a bummer, but oh well. Yeah, we're able to actually just start buying cool things, like a Viking helmet and Quoogle glasses. I like that. All right, cool. Create a text with similar style. Hello, I'm a very famous writer, but I'm lazy. My fans want me to write the next book of Song of My Colden Walkers series quickly, but I want to jump on a trampoline. Could you create a program which could write a book instead of me? And we need as many deaths as possible in that book. All right, I love it. 50% accurate. Recurrent Neural Network wrote a book. What? Oh, right. Okay. In summer of 2017, Zach Tutt, a programmer, created a RNN, recurrent neural network, that predicts the events of George R. R. Martin's 6 books, The Winds of Winter. Ooh, the neural network wrote the end of the story by analyzing the plots and style of the last books. Chapters written by the program confirm many fan theories. That is interesting. That is fascinating. I would like to read that. Ooh, okay. What? RNN layer. This node sockets are divided into two types, basic sockets and memory sockets. The node is trying to predict the next letter in the sentence based on previous predictions. Okay. What? This feels like it could use some hand holding. Does this go into... Okay, so this goes into here. What does this even do? Okay. Let's do that, I guess. Go. Nope. No. Nope. What even are we doing? Okay. Let's just have this feedback on it. So it's trying to remember what it saw. So it's going to get these letters, and then it's going to try and remember what it saw. Maybe this is going to fix it. Let's see. Its error rate is still the same, isn't it? No, I'm confused. I don't know how this works. Can this go to here? No, it can't. Okay, so it's got these two layers, which is fine. All right, let's throw a stochastic. Stochastic. I don't remember how to pronounce things. Words are hard. Is this going to reduce? This does reduce the error. Cool. 24%, but not quite 50%. That's a bummer. Okay. Wait a second. Does this go? Can this go out to here? We're trying to predict the word, so really... What? Okay, so these letters... Let's watch this going in a little bit slower. Huh. I'm so confused. But okay, let's... Well, our error has gone down, so... So it is looking at the sequence of letters and then trying to figure out what happens. Oh, okay, so it did type out hello world, it looked like. It's looking at the sequence of letters and trying to predict what happens next given what it sees the order of things going in. Just a little bit confusing. But okay, that's... This whole idea of just hooking it into itself seems kind of weird. Unless there's some other way I ought to be doing this, but I don't think that's the case. No. I mean, this really is just, hey, I mean, they're trying to indicate to you that, hey, you're looking at this information and remembering what you saw. So if you're looking at print, you're saying, hey, I saw an R, but last time I saw a P. So R's follow P's a lot. And you go, well, that must be how words work. You kind of predict how likely it is that you see one letter given the letters that you've seen before. But this is just sort of weird. And the whole idea of just kind of using this gradient descent things as sort of magic error reducers is a little bit weird for me. But whatever. It's not, I'm not here to judge. And their accuracy is getting better, so whatever. Okay, lots and lots of money. We're past, oh, okay, and we get our startup information. Money. Okay. I feel like we ought to jump into another startup, but our startups are doing just fine. There's no real reason for us to cash out of any of these. Let's see. It feels like is this the end game? Because we're not able to buy more stuff, so I feel like we're kind of running through what we're able to do. Although it could just be that there's more to be added. But it feels like we have enough money to just kind of throw lots of stuff at random things. Okay. Now that we have $18,000, we really could just go through these tasks and throw crazy load balancers, although it's not giving us those. Anyway, WTL developers. Ooh, Well True Learn developers are messaging me. Description generator. Hello, we are the developers of the Well True Learn game, and we've made this task especially for you. Our game will be released in Steam soon, so we must write a short description of our game. You need to create a program that auto-generates small texts that can fit the role of the game's description. Please do it as fast as you can. It helps us in creating a wonderful game. Well, that's a fun little meta task. Okay, this looks like it's just the same thing. Now, here's a question. If we're using this whole layer, this recurrent neural network layer, is that, but the letters are ordered. So if we're throwing data, I'm confused. I'm very confused. Okay. I mean, I guess let's just train it and see what happens. All right, so this gets better. We have 41 seconds. We're not going to end up there in time. I guess now that we're not training, we don't need this in front of things. Right? We can just throw that there. Let's do so. Okay, so we have 58 seconds. Let's see how many things we get through. It's not even a little bit accurate. Wait. Learn, Well True Learn is a simulator of machine. We're not going to get with specialist who uses visual programming. Right. I mean, this is cool. I'll give it that. We didn't get quite enough information. I guess we can just, throw stuff in front of it. And instead of training another layer, oh, of course, it is going to be mad at me. It's going to make me train it. Fine, we'll train it. But this part is weird to me because it means we're going to be splitting. If the whole point is to train things based on the sequence, then aren't we throwing things off by splitting these things? I mean, the error should not improve then, should it? Well, it did. Okay, fair enough. But that doesn't make sense. If we're splitting, so basically everything is only getting the letter each of these is only getting every other letter, so we're training on bad data, but whatever. That's a little confusing, but it's okay. Oh, no, now we're okay. Is a simulator of a machine visual programming into mate. Okay, there we go. That is that. Is this the end? Have we completed our quest? I mean, it feels like it. All right, success. Next project. Oh, there we go. Congratulations. Is this the end? Of course not. This is just the beginning. Our game's in development. New levels and improvements await you in the nearest future. Subscribe to Litten.io, twitter.com/Litten.io, twitter.com/WellTrueGame, and stay tuned for more info. So there we go. We have completed this game. Congratulations to us. This was fun. I'm excited to kind of see where this goes. There's still a startup that we have to look at. Where is that? Under mail, right? Yeah, there's one startup that we have yet to look at. Actually, let's sell off the blood center real quick, and we'll look at that startup. Because hey, why not? Soap making business, yeah, by Tyler Durden. Cool. We created a soap making startup, yet we need some help in another department. Well, let's say so. Organize an underground sports competition to find the best loaders for our business. Now we need a programmer who will be cool enough to write an algorithm which will allow us to understand who suits the job better based on the applicant's physique and success in those competitions of ours. And the most important part of the deal is to keep silent about it. All right, well, hopefully sharing information on the internet is not a problem. Okay. Okay, this doesn't seem too bad at all. Yeah, this seems nice and straightforward-ish. Yeah, this stuff only has to be accurate. It doesn't have to be load balanced. We don't have to distribute the traffic equally. Bum. That's that. I mean, we're good. That's nice and simple. Let's go ahead and release it. I mean, it could be faster, but that's fine. Okay, we can accept the job. Sure. Oh, interesting. We can accept the job again. I wonder if this will let us actually advance the clock by a day, so we can see how that startup happens to be going. Oh, this is actually, it looks like this is, oh, okay, never mind. I was going to say it looked like it was getting more accurate, but that's not the case. Okay, there we go. We do end up with the little message again. But yeah, this has been an interesting game. I'll be excited to kind of take a look at it after it's been developed a little bit further. It does feel like some of the more machine learning-y stuff is a little bit watered down. It's just kind of, hey, throw this gradient descent thing at it and it magically makes the error go away, which is a little bit of a bummer. But hey, you know, a lot of this is very clearly still under development. I'm excited to see where this goes. And I hope you've enjoyed watching these with me. It's been fun to play this. And if you see other games that are like this, please let me know, because it'd be fun to go through these. That's all I'm saying. So with that, I will bid you a farewell. And I'll speak with you again soon. Cheers.